Welcome to the session. Today we are going to see about mathematical calculations of elastic collision in one dimension. Elastic collision in one dimension. See here, shown in figure, I am taking two objects, two bodies. And the mass of first body is m1. Mass of the first body is m1 and the mass of the second body is m2, and also whose velocities are u1 and u2 respectively. Okay, now after the elastic collision takes place, let us assume whose masses are same, m2, here it is m1 mass of the first object and m2 mass of the second object. And what about whose velocities? Let us assume velocity of first object is v1 and velocity of second object is v2. Velocity of first body is v1 and velocity of second body is v2. Already I told you in the last class, I've seen different types of collisions: elastic, inelastic, semi-elastic collisions. And also, so what is called elastic collision, what is inelastic collision, and what is semi-elastic collision? See there, in elastic collision especially, elastic collision, there should be momentum, conservation of momentum and the conservation of energy holds. See here, so conservation of momentum. Let us take first formula, conservation of momentum. See, what is conservation of momentum? Momentum before the collision must be equal to the momentum after the collision. That means there is no change in momentum, right? So momentum before the collision. See here, m1 u1, multiply m1 u1. So m1 u1 plus m2 u2, that equal to momentum after the collision can be written as m1 v1 plus m2 v2. Momentum before the collision and momentum after the collision. Assume this is equation number 1. Let. And so elastic collision, there must be conservation of kinetic energy also satisfied. See there, kinetic energy of first body of m1 u1 square and kinetic energy of second body of m2 u2 square. So this is the kinetic energy before the collision, total kinetic energy before the collision. Then kinetic energy after the collision, where we have to take kinetic energy of first body of m1 v1 square plus of m2 v2 square. So let us assume this is equation number 2. This is equation number 2. See here, conservation of momentum. First law represents, equation 1 represents conservation of momentum and equation 2 represents conservation of kinetic energy. By using these two equations, we are going to derive equation for v1 and equation for v2. Final velocities of the objects after the collision. Let us see how can we solve that equations. So it's very easy. See here what I am going to do here. Let us take equation 1. From equation 1, see here, from equation 1. So what I am doing, m1 u1, let us bring this term to the left side and send this term to the right side. See, minus m1 v1, m1 u1 minus m1 v1. Similarly, that equal to m2 v2, that equal to here, which remains same, m2 v2 minus m2 u2. So from this equation, let us take m1 common here. Taking m1 common, what we get here? u1 minus v1. So that is equal to m2 common, v2 minus u2. v2 minus u2. m1, u1 minus v1, that equal to m2 into v2 minus u2. Right. Now assume this is equation number 3. Similarly, from equation number 2, see this side off cancelled, and what we get? So from this equation, see here what I am doing. So let us send off m1 v1 square into the left side and off m2 u2 square to the right side. See there, I'm taking m1 common here, and what we get there? If you take m1 common, we'll get u1 square minus v1 square, that is equal to m2 common. What we get there? What we get there? v2 square minus u2 square. And also you know that a square minus b square formula, this can also be written as a plus b into a minus b. a square minus b square is equal to a plus b into a minus b. See there, m1 into u1 minus v1 and u1 plus v1. So that equal here m2 into v2 plus v2 minus u2 and v2 plus u2. Okay, so assume this is equation number 4. That is equation number 4. So from equation 4 and 3, see there, from equation 4 and 3, let us do here 4 by 3. 4 by 3. See what we get if we take 4 by 3. See here, m1 u1 minus v1 u1 plus v1, that equal to m2 v2 minus u2 into v2 plus u2 by, here what we get? m1 into u1 minus v1. Okay, so here what we get there? m2 into v2 minus u2. So what we get finally here? m1 cancel, and also u1 minus v1 cancel, m2 cancel, and also v2 minus u2 cancel. So what we get finally? u1 plus v1 equal to, what we get there? v2 plus u2. u1 plus v1 is equal to v2 plus u2. So rearranging this equation, again we'll get there u1 minus u2 equal to difference of initial velocities, u1 minus u2 equal to, so what we get? Difference of final velocity. Take minus common, and here we will write v1 minus v2. So let us consider, this is the important equation. Assume this is equation number 5. This is equation number 5. Now let us see what we do here. Okay, let us remember equation number 3 and equation number 5. So from equation number 5, see here what I am going to do. V1 equal to, from equation number 5, V1 equal to, what we get there? V1 equal to, from equation number 5, V1 is equal to, so what we get here? V1 equal to, so V2 plus U2, so it will become positive, and V2 plus U2 minus U1. So assume this is equation number 6. equation number 6. So from equation 5, so I'm writing this one as v1 is equal to v2 plus u2 minus u1, and substitute equation number 6 in equation number 3. If you substitute equation number 6 in equation number 3, what we get there? See here, in place of v1 we are going to substitute this term, right? So u1 and v1 means minus v2 minus u2 plus u1, so that equal to m2 v2 minus u2. Okay, right. So from this equation we are going to find out v2. So velocity v2 we are going to find out. See how can we find out v2 value? Right. So let us multiply m1 inside plus m1 u1, that is equal to m2 v2 minus m2 u2. Okay, see here. So from this equation we are going to find out v2 value. Let us see how can we find v2 value here. v2 value. See how can we get v2 value, and here we have to take this term this side and this term this side. So what do we get finally here? Okay, multiply inside. So what we get there? Okay. Let us send this term this side, and what we get here? m1 u1 minus m1 u2 plus m1 u1, and send this term this side, and plus m2 u2, that equal to, and v2 taking common, then we'll get m1 plus m2 here we'll get. So finally what we get here, take this term this side, and we have the term 2m1 u1 plus m2 minus m1 into u2, m2 minus m1 into u2, right? So that equal to v2 into m1 plus m2. So from this equation what we get there? v2 equal to what we get there? 2 m1 u1 by m1 plus m2 plus, so m2 minus m1 by m1 plus m2 into u2. So this is the resultant equation. So this is the resultant equation, velocity of second body after the elastic collision, velocity of second body after the elastic collision. Now next we are going to find out velocity of first body after the collision, velocity of first body after the collision. Let us assume this is equation number 7. Now, so how can we find v1 value? See there, from equation number 5 we'll also write v2 equal to what we get here? v1 plus u1 minus u2. v2 equal to v1 plus u1 minus u2, and substitute this one in equation 3, right? Substitute that one in equation 3. See there what we get. If you substitute in equation 3, we'll get v1. So v2 is there, and substitute that one in equation number 3. That is what equation number 3 here, right? Equation number 1. Substitute equation number 3. Equation number 3. What we get? The m1 into, what is equation number 3? m1 into u1 minus v1, u1 minus v1, m1 into u1 minus v1. So that equal to m2 into v2 minus u2, v2 minus u2. Substitute v2 value in this equation. m1 into u1 minus v1, that is equal to m2 into v2 value. What is v2 value? v1 plus u1 minus u2 and minus u2. Let us expand this equation. m1 u1 minus m1 v1. Here we are going to find out v1 value, and m2 v1 and plus m2 u1 minus 2 m2 u2. Okay, so let us send this term this direction here and this term here. Then what we get here? m1 u1, taking this term this side, and minus m2 u1. So plus 2 m2 u2, 2 m2 u2, that equal to, so that equal to, so what we get there? Taking this term this side, then take v1 common, then we get m1 plus m2, m1 plus m2. So finally what we get here, see here, so v1 equal to, so what we get here? m1 minus m2 by m1 plus m2 into u1 plus 2 m2 u2 by m1 plus m2. So this is the second one. So assume this is equation number 8. That is equation number 8. So this is the velocity of first body after the collision, and this is the velocity of second body after the collision. So in this way we will derive these two equations. Now let us see the different cases. What are the different cases? Let us see. Now case 1. Case 1, here what I am assuming? I am assuming m1 is equal to m2. What I am assuming? m1 is equal to m2, that is equal to m. m1 is equal to m2, that is equal to m, and substitute that one in given equations. So what we get in the equation number 8, first term disappear because there is m1 minus m2, it will become 0. And here what we get, see there, if you substitute in place of m to m, here we will get to 2m, mm cancel, 2 to cancel, we will get u2. Then if you substitute m1 equal to m2 is equal to m, then we will get v1 is equal to u2. v1 is equal to u2. And from equation 7, what we get there? Second term will be disappear, and here also we will get v2 equal to u1. So what happened in this case? If the masses of the bodies are same before the collision and after the collision, they exchange their velocities. So what happened? The first body after the collision, first body gets the velocity of second body before the collision, and the second body gets the velocity of first body before the collision. So this is so happen in case of masses of the bodies are same before the collision. And now let us see the second case when u2 equal to 0. Second case, case 2, let us see here. Here we will see case 2 when u2 equal to 0. That means second body before the collision, only first body is in motion and the second body is in rest position. That means what? U2 equal to 0. If you substitute u2 equal to 0 in these equations, what we get there? If you substitute u2 equal to 0 in this equation, see here v1 equal to, if you substitute u2 equal to 0, second term of the 8th equation will disappear, and finally we have the term m1 minus m2 by m1 plus m2 into u1. And similarly v2 equal to what? Here second term up disappear, and finally we have 2m1 u1 by m1 plus m2, m1 u1 by m1 plus m2. Now what I am assuming, let us consider case here m1 is equal m2 is equal to m1 is equal to m2 is equal to m. Substitute. Then what we get finally here, if you substitute this condition, if you take this condition, then v1 equal to 0 and v2 equal to what we get there? If v1 equals 0, it will become 0. And what about v2? Substitute here 2m get cancelled, we'll get v2 is equal to u1. So what happened in this case? In this case, if you take u2 equals 0, second body is in rest position and their masses are same, then what we get? v1 equals 0. The velocity of first body after the collision will become 0 and the velocity of second body will attain the velocity of first body after the collision. See what happened here? The total velocity is imported to the second body. Total velocity is imported to the second body after the collision and first body remains in steady position. Okay, so this is so happened this case. And the next thing is same case what I am taking if m2 is greater than m1. If m2 is greater than m1. See here the case 3 assume. Here same case u2 equal to 0 and m2 is greater than m1. If m2 is greater than m1, what happened in this case? If m2 is greater than m1, so what happened in this case? See the picture, m2 is greater than m1 and u2 also 0. So in this case what happened? Let us make it m1 equal to 0. Because m2 is greater than m1, comparing to mass of the second body, first body is negligible. And substitute, take this condition, substitute in this equation, see what we get. If you substitute that condition, what we get there? See here in the equation, v1 is equal in this equation. So m2 is greater than m1. So m1 cancel. Let us remove m1 and m2 cancel. Finally, we'll get v1 is equal to minus u1. v1 is equal to minus u1. And what about here in this term? See what happened? m2 is greater than m1, then m1 will become 0 and v2 is equal to 0. v2 equal to 0. So what happened in this case? What happened when the lighter particle collides with much heavier particle at rest? The lighter particle rebounds with the same velocity while the heavier particle remains approximately at rest. See here, especially in this case, what I am taking second body is heavier than the first body. See, this is the first body whose mass is m1, whose velocity is u1. And what I am taking bigger, heavier body whose mass is m2 and there is no velocity, u2 equal to 0. If the collision takes place between them, after the collision what happened? There is no change in position of second object, but first body rebounds with the same velocity in the negative direction. Minus represents negative direction. That means what happened after the collision? Second body mass remains same and it is also in rest position. But what happened here? The first body rebounds with the same velocity but in opposite direction. So what we get there here? v1 is equal to minus u1. So this is what so happened in the case 3. So that is what the second body is heavier than the first body after the collision. What happened? Here it is. Now the case is if m1 is greater than m2. If m1 is greater than m2, apply to this condition. If m1 is greater than m2, what happened in this case? What we get here from this equation, if m1 is greater than m2, remove m2, we will get v1 is equal to u1 because m1 get cancelled. And what about v2? In this case, we'll get V2 is equal, so M2 is 0 and M1 cancel, we'll get 2U1. See there, if you observe these two conditions, see here, picture represents like this. See here, first body is heavier than the second body, where M1 is greater than M2. And whose velocity of first body is how much? U1, and velocity of second body is 0. And after the collision, what happened here? See, first body have same velocity just like before the collision, but the second body that is in rest position, that is lighter than the first body, then after collision it gets velocity double of the velocity of first body. That means it gets after collision, the heavier body velocities remain same, v1 is equal to u1, but smaller one having velocity here, v2 is equal to 2u1. So in this way we see the different cases case studies here. Okay, so with the help of this calculation, we'll find out what happened during the accident process. After the accident, we'll see how much distance the bodies gets after the accident. Okay, so this is the topic today we covered, and tomorrow we'll see again what is inelastic collision, how much energy loss takes place in inelastic collision, and also we'll see the equations, final velocity equations in tomorrow's class. Thank you very much. This is the end of the topic. Thank you.